Good morning. Good greetings. I am Jamaica Delayot, and today I will be performing Wilcoxon sign rank test in SPSS and Excel. What is Wilcoxon sign rank test? The Wilcoxon sign rank test serves as the non-parametric counterpart to the dependent sample t-test, specifically designed for a situation where the assumption of the latter, particularly regarding metric, interval, or ratio, and normally distributed data, are not met. This test is particularly useful when dealing with rank or ordinal data, making it an excellent alternative for analyzing repeated measures or paired observations without requiring the data to follow a normal distribution. So the key features of Wilcoxon's sign rank test is two, which is the non-parametric nature and W statistic. We look at the statement problem we're going to solve. A psychologist wants to test whether a new mindfulness training program reduces participants' stress levels. The stress levels of 10 participants are measured using a standardized scale before and after the program. Since the stress data may not be normally distributed, the psychologist uses the Wilcoxon sign rank test to evaluate whether there is a significant reduction in stress levels at the significance levels of alpha level equals 0.05. And look at the steps in solving the hypothesis. Step 1 is state the hypothesis. First of all, we're going to go to our Excel. This is the data set for the participants. We have 10 participants. So state the null hypothesis. Before, the null hypothesis is before equals after. The alternative hypothesis is before not equal to after. Our alpha level is 0.05 and the number of participants is 10. So we're going to compute the difference of both before and after. So this is the formula for solving the difference. After minus before. So 40 minus 45 is equal to negative 5. 45 minus 50 is equals to negative 5. And 39 minus 42 is equals to negative 3. And 46 minus 48 is equals to negative 4. And so on. This is all the differences of after and before. We're going to put now the absolute difference. We're going to just remove the negative signs we use in difference. So copy this and paste. This is the. So now we're going to rank all up. First is the participant 10 because the absolute difference is 1. And the rest will be this. That is the rank. After that, we're going to know the critical value of the alpha level 0.05. Our alpha level is 8. No, our critical value is 8. The number of participants is 10. Two-tailed, and we got 8. We got 8. Critical value 8. Before that, and now going to know the step 3. Sum of positive graphs is 0. And the sum of positive is 0. Sorry. Since there are no positive and only differences, the sum of the is positive. showing the sum of positive ranks is 0. In step 3, we go W minus the absolute value of 8.5 minus 8.5 minus 5.5 minus 3 minus 7 minus 3 minus 7 minus 5.5 minus 7 minus 1 equals to absolute value 55. Now we will going to determine the critical value. We already determined the critical value, which is 8. After that, we are going to compare. This is the step 5. Compare the W with the critical value. So here it is. The answer is we reject the null hypothesis because W equals to 0 less than 8. After comparing it with the critical value, the step 6 is interpretation. At the alpha level 0.75, there is statistically significant evidence at the alpha 0.05 level to conclude that the mindfulness training program reduced stress levels in participants. The difference in stress levels before and after the program were predominantly negative, indicating a consistent reduction in stress after the program. The test results supports the effectiveness of mindfulness training in lowering stress levels, and that's how we do it manually in exam. Thank you for watching. Greetings everyone, my name is Jamaica De Leon and I'll be performing the Wilcoxon rank test in SPSS. Here's our data set. I already have the sample set, but first we're going to fix them in variable view. Here our variable view. We have the name, type with decimals. This is optional. You can add 2 decimals or more decimals, but I prefer 0 decimals. Label, values, missing, columns, and align. The most importantly is the measure. We need to put the 2 of the set in scale. The name is this, before and after. Our independent variable is before, and our dependent variable is after. Going back to the data set, data view, rather, this is our data, the variables or data set. In this, we have 10 participants or numbers. We are now going to analyze using Wilcoxon. To analyze, we need to click the Analyze, find the non-parametric test, find the legacy dialogues, and find the 2 related samples. Here, the packs will appear. This is the before and after our 2 dataset. We need to put the 2 dataset in this variable 1 and variable 2. Before is variable 1, and after is variable 2. Just put them using this arrow. Now the exact asymptotic only. Click that and click continue. The option will be descriptive or quartiles. This is optional too. Missing value is exclude cases test by test. Click continue. The test type will be Wilcoxon. Click OK. After we click OK, the result will come out. The result will appear. We have the first table is the descriptive statistics. Second table is the results of Wilcoxon track test. And the third is the test statistics. In the test statistic, we have the asymptotic, the two-tailed, which is 0.005. But our critical value is 0.05. So 0.005 is much smaller than 0.05. To conclude that there was a significant difference between the two data sets, and to prove that there are significant and improvements if we see the percentile 58 or median. The before is 46 and the after is 42. This is the sign that there is a significant difference between the two sets. And that's how we get the Wilcoxon sign rank test on SPSS.
For our key takeaways, its value ranges from -1 to +1. For our key takeaways, its value ranges from -1 to +1. A coefficient close to 1 indicates a strong positive correlation, while a value near -1 signifies a strong negative correlation. It is essential to recognize that Pearson correlation only assesses linear relationship and may not accurately reflect associations that are nonlinear. Additionally, the coefficient is sensitive to outliers, which can skew results and lead to misleading conclusion if not properly addressed. While the person provides valuable insights into relationship between variables, it does not imply causations requiring further analysis to establish any causal links. The Spearman's rank coefficient, commonly known as Spearman-rho, is a non-parametric measure that assesses the strength and direction of association between the two rank variables. One key takeaway is that it is particularly useful when the data does not meet the assumptions of normality required for Pearson's correlation, making it more suitable for ordinal data or nonlinear relationship. Additionally, Spearman's-rho can effectively identify monotonic relationships, meaning that it can detect consistent increases or decreases in one variable as the other variable changes. Regardless of the form of the relationship, another important aspect of Spearman's-rho is its resilience to outliers, as it relies on the rank of the data rather than their actual values. The Wilcoxon sign rank test is a non-parametric statistical method used to compare two related samples or match observations, making it particularly useful when normality cannot be assumed. One of its key advantages it is ability to handle ordinal data or continuous data that that does not meet the assumptions of parametric tests, such as the paired test, since it makes fewer assumptions than its parametric counterparts. It offers a reliable substitute for small sample sizes. And that's all for our output. Thank you.